Hi folks, we're going to take a look at number 3 from the assignment. So let's take a look at it here. It says that a plane takes off in a straight line and travels along this line for 10 seconds. When it reaches a height of 300 meters, if the plane is traveling at 60 meters per second, at what angle is the plane ascending? All right, so let's start by trying to draw a diagram here. So if we've got, say this is the ground, and the plane takes off and it moves in this direction for 10 seconds until it reaches a height of 300 meters. Okay, so the height, of course, is measured vertically to the ground, and the plane is not traveling horizontally, it's rising, it's ascending because it's taken off. So this represents the distance the plane travels. Okay, but they don't give us that distance directly. They tell us that it travels at 60 meters per second for 10 seconds. Okay, and of course, we know that the distance can be written as the velocity times the time. So here, if I want to find this distance, I just have to take the velocity of 60 meters per second times 10 seconds, and we have 600 meters. Okay, and what they want is the angle at which the plane is ascending. So in other words, the angle from the plane's motion to the ground. So I'll call that theta. So here we see that we've got a right angle triangle with two side lengths, and that's enough to solve for whatever we like. So in this case here, since I've got the opposite to theta and I have the hypotenuse of the triangle, I'm going to use sine. So we can just write a nice simple equation. Sine of theta is equal to 300 over 600. And so theta, in order, what's the opposite operation of sine? It's inverse sine, is inverse sine of 300 over 600. Well, of course, that's just 1/2 unified. If it wasn't easy to do, I would just leave it as a nice easy fraction, but here we can write as 1/2. So what do we have? We've got sine inverse of 1/2 is equal to 30. So 30 degrees. Okay, so main thing here is to make sure we get the correct diagram, because then from there, the actual trigonometry was quite easy. So here I think the trick was to realize that speed and time at which it's traveling is along the line of motion, which represented the hypotenuse of this triangle and not this adjacent side along the ground of the triangle. Okay, that's it for this one.